So let's actually play around with this a little bit. Little bonus material here. Let's get a really big sample from this. Let's look at what this distribution actually looks like. Let's plot. Let's write. Okay. Let's see what this looks like. Okay. So this is our joint density. And what I've done here is I've gotten my sample, in this case of 100,000 people. And depending on their values of X and Y, I've kind of, each of these points, I've like, imagine again, I've asked that person to go stand there in this place. And then I'm looking top down and I'm looking at where it's crowded and where it's not crowded. And this is what it looks like. And does this make sense to you? So let's think about this. Because what I said, the way that I generated this data is that I first specified that X is a standard normal distribution. So let's actually just plot X. Maybe the fastest way is like this. Okay, so if I just plot the histogram of X and the sample is, again, this is not the whole population, it's just a sample, so it's not going to be perfectly normal, but it's not going to look perfect, but it roughly follows this kind of normal distribution. So what is this? What am I looking at? Well, if I looked at the joint, if this is the joint density, what I'm doing by getting the marginal is that I'm adding up along the y-axis. So I'm taking this picture here and I'm squishing it down like this, and then I'm looking at it from the x-axis, as if I'm kind of standing where this x is, and I'm looking up that way. And I've squished all the y-axis values, so everyone who's standing like along this line has all been squished, and they're all standing on top of each other at this point. Everyone who is kind of anywhere along this line, I've squished them all down, and they're all standing on top of each other at this point. And what I see when I do that is this, okay? And oops, sorry. This should actually make some sense to you if you look at this picture, because on the tails, so when X is small or very big, you're not seeing a lot of people, right? So even if you add up all these people, there's not a lot of people standing here. But the further in you get, and maybe this would be more evident actually if I made this size smaller. Let's see. Yeah. So yeah, maybe that's nicer. So you can see it gets along each kind of stripe of X, you get more and more and more people as you get further in towards the center at X equals 0. And so that's why when you look from the side and you make everyone stand on top of each other, it looks like this. Now, what about this conditional distribution of y that we were talking about? So that you can approximate the conditional distribution by getting the sample and just like filtering. Let's say, what's the conditional distribution of y given that x equals 2? So I'm going to filter my sample to say x equals 2. Now this isn't going to work because there actually is, I can show you this, there's nothing here. Why? Because x never takes exactly the value 2. So that's not actually what I want to do. I need to approximate that by saying, x is kind of like, between 1.9 and 2.1 or something like that. Okay, because I need to get somebody in there, and this also doesn't work. I have to do it like this. So okay, now there's some. Now that I have some data in there. So I'm going to get that sample, and then I'm going to make the histogram of that. Let's do. I think I already showed you this. if this does not make sense to you, or I didn't explain this earlier, Google this little symbol, ask ChatGPT what it is, how to use it. It's from the Magrider package. Okay, so this is the histogram of y, conditional on x being roughly 2. So again, how do we relate that to this picture here? What I'm saying is, like, for let's say this is the value 2. For x is roughly 2, I'm going to take, I'm going to stand on where this y is on the y-axis, and I'm going to look that way at this picture. But I'm going to get rid of everyone who's standing anywhere except for the people who are standing at this like line where x equals 2, roughly speaking. What does that look like? And so if I do that, I see that it looks like this, which is, roughly speaking, uniform between -2 and 2. Okay? And that's exactly what we specified here. So when x is 2, y should be uniform between -2 and 2, which is what we're seeing. Okay. So hopefully that helps you relate the marginal distribution, joint distribution, and this is a conditional distribution actually, because I've filtered before I've made it. So if I want to, if you wanted to be presenting this, you should maybe retitle that to histogram of y given x equals 2. So I've shown all that. Another interesting thing is that we know that this distribution, which I'm just going to kind of shorthand like this. I know this joint distribution is the same as the way that I've kind of implicitly done it in the structural equations model is first sampled from the marginal density and then this conditional density of y given x. But we know that we can also mathematically, there is some way that this has to be able to factor this way. But what I've given you here, it's really easy to read off this factorization from this. It's not so easy to read this factorization. You could get it. What you would have to do though is first calculate the joint density, which we did. Mathematically, I have that function. And then if you wanted to get this condition or this marginal density, you would have to integrate this over x to get this. Because remember, if you have a joint density, you can get any conditional or marginal. But you'd have to do some math to do it. And then similarly, to get this thing, you would then have to divide this by this. So I could write out what these things are analytically, but let's actually just see computationally if we can get an idea of what those look like. So because for here, there's nothing that tells me what the marginal distribution of y is. I know what the conditional distribution of y is for any value of x. I know the marginal distribution of x, but I don't know what the marginal distribution of y is, at least not at first glance. But let's see what that looks like. If I look at this picture, I should be able to kind of intuitively guess at what maybe the marginal distribution of y should look like, because what that would be is like for a given value, like let's say here, y is this value. I'm going to take all the people who are standing on this line, and I'm going to pile them up all right here, and then do that for every line, and then I'm going to stand where the y is, looking that way, and see what shape that makes. And so let me just show you what that looks like. We can do hist y, right? That's all that is. Let's so actually, why don't you pause the video right now and just think about it? Think, what should that look like based on this plot? So here we go. It actually looks like this, which is kind of interesting. I don't really know off the top of my head, what kind of a distribution that is, or it has a name or something, but I could, like I said, theoretically derive what that density is if I did some integration. But that's interesting. And you know what? Let's actually make more bins. I think. How do you do it? Oh, breaks. Okay, cool. No? There we go. Okay, so yeah, just to get a little finer resolution on that. That's kind of interesting. So it's not, I mean, it's not totally like a normal. So a normal, I would expect more kind of like this. So it seems to be more kind of like peaked, something like that, which is kind of interesting. And again, you could work it out exactly if you want. If you do, that's cool. Put it in ed, calculus people, or put it into Wolfram Alpha, can do calculus for you. All you have to do is set it up. So you have to take that joint density we computed and say integrate out x. And that will be this is a function of y, and you could plot that using the kind of method to plot functions that we talked about earlier, and compare it to this and see how it actually should look. Which is cool. Okay, so let's look at something else. Let's look at, so here we were plotting the density of y given that we know x. But what if we flip it the other way? What if we say, given, so that's fixing x, looking at a long line here. We're standing over here and we're seeing how many people are kind of piled up, or what the distribution of people is along one of these lines. Let's flip it and say we're standing down here. Let's fix y to be, let's say, -2, and say what's the distribution of people along the y equals -2 line, or -1 line. And you can already see, based on this picture, what that might look like. Think about it yourself if you want, but I'm going to draw what I think that's going to look like. And like down here, so this is going to be my plot down here. So here's my axis. What I think this is going to look like, so let's say I'm choosing to look along this line here, like y equals 1 or -1. So over here, there's very few people. So the value is going to be low. And then I get more and more and more people up until here, right? Something like this. And then suddenly here, I get nobody. And then there's nobody for a while until here I suddenly get a bunch of people. And then I get maybe like fewer and fewer and fewer people, something like this. So that's what I think it's going to look like. And let's see if that holds up. So what I need to do here is flip these things around. So I'm going to ask about values where y is, I was doing, let's say, -1, -0.9 to sorry, this one should be -0.9. And this one should be like -1.1. And then I want to plot the histogram of x there. Let's check it out. All right, that looks pretty much the same. So if, and let's make this finer. Yeah. So that's more or less what I expected to see. You see there's a decrease here, but that's because of this. I'm not actually getting the values where y is exactly 1. It's between -1.1, and so I could kind of make those drops less if I asked for kind of like tighter things here, some 5, but then there's less data overall. So it gets kind of more choppy. Yeah, but you see I'm making this go away, these little bits right here. But overall, the shape of this looks remarkably like what I drew here, just from looking at that joint distribution and thinking about what should be going on. Okay, so hopefully that was helpful. That's all kind of like live bonus material. Let me know in the comments below if you enjoyed it.